Well, this is something some of you guys are probably pretty familiar with. I did attend a class one time when I was up at KC Vision, and the instructors were talking about this, and there was an element of it that apparently they weren't aware of, but it's a really good engine health thing. This is something I taught my students at the college for a while, and it they seem to be able to use this method to find out things that were difficult to find out in other ways. And so we're going to jump into this thing right now, and then there will be a test at the end that's going to play in a video format, and it'll basically work its way through and then give you the answers at the end, so you're used to the way that I do that kind of thing. Well, compression tests are about as old as engines, and just about everybody that's ever done engine work has performed one and used the extra used the data to submit a diagnosis. You can get an idea of what this engine's doing as far as how each cylinder is breathing by the way that you measure the compression. And the lowest, there's some numbers that vary on that, but they say the lowest shouldn't be any less than 70% of the highest whenever you're doing compression. You need to get you a good compression gauge, though. It's really important to do that because you can get a crummy one. You might even see one that the little Schrader valve in the bottom of it tends to get messed up or fouled or something, and instead of the needle going up and holding the readings, it'll bounce, back and forth, and it's seriously aggravating when it does that. Well, a dynamic compression test is a really significant diagnostic tool, but it's very seldom used. That's the dynamic compression test, is checking the compression with the engine running. Now, it can be used to pinpoint the cause of a misfire when all the usual tests don't reveal the problem. Alright, so static compression and cylinder leak down just checks how well each cylinder is sealed against compression loss. And you can connect a vacuum gauge to measure manifold vacuum and determine an engine capacity to breathe, 18 to 22, see in the green there, but that doesn't typically pinpoint which cylinders have a problem. Alright, and so a running compression test provides the quality of a particular cylinder's ability to breathe, its volumetric efficiency. Some of you guys are familiar with these graphs, these pressure graphs. Each cylinder is supposed to pull air in, retain it for the correct amount of time, and then release it into the exhaust whenever the combustion event is done. If a cylinder can't perform, the result can be a loss of volumetric efficiency or a density misfire. In other words, it can be not dense enough in that cylinder for it to fire and cause any kind of push on the piston. And of course, I got a little PO304 there. Building a chart is really simple. This chart for a 4-cylinder, make sure your chart's got enough cells. This one has 16, a 6-cylinder. I say 16, that's actually 16 if you count these over here. It'd be 12 the other way. A 6-cylinder would be 36, an 8-cylinder requires what? You got 4, you're going to have, okay, so what's 4 times 8? See that if a 4-cylinder has to have that many, you do the math, figure it out. You can tell if you've got enough. You got 3 columns here, static, idle, and snap. All right, now let's look at, you obviously begin with a static compression test. Put those numbers in the column under static. That's what you're going to write right in there. See, that's your static compression test. Next, you start the engine with your gauge in place and take idle readings while holding the engine at about 1200 RPM, which is just above idle. Okay, so you can actually watch that needle and you can tell what kind of a reading you're getting. Now, you got to remember that a dynamic compression test is only going to be about 30% of what a static compression test is. So if you've got 180 pounds of static compression, 6 puffs when you're spinning it with the throttle wide open and all the other plugs out, then you're only going to get about 60 on the average with static compression test because of volumetric efficiency. That air's got to go in there and make a lot of curves before it makes its way into the cylinder. It's happening a lot faster. The engine's running faster than it can draw in air like that, unless it's a turbocharged or supercharged engine. Put those numbers in the idle column. Okay, put all the spark plugs back in place except the cylinder you're checking and short that spark to ground on that one. Don't just leave the spark plug wire disconnected, because that spark's going to find somewhere to go and it may go back and find something you don't want it to find. Alright, so just giving you your idle numbers. Notice these numbers are a lot lower than that other one. Alright, snap the throttle to 2500 and release it. Now you're doing this one cylinder at a time. All the other cylinders have got to be operating normally, and the one that you're checking is going to give you these numbers. Record the results in the snap column. These numbers should be at least 80% of the static reading when you snap it. Now you may have to snap it several times to get a good, solid reading like you're looking for. But notice how this one here, I've got it painted yellow, is reading 85. You see a problem there. Alright, so if the snap reading is below 80% cranking compression, it's not able to get the air it needs. Worn intake cam lobe, intake valve carbon deposits, weak valve springs, worn valve guides, rocker push rod problems, intake manifold runner issues. And so basically, if one of them's low, you notice how nothing really showed up static or idle until you did the snap. That's giving you information you didn't have before you did this. It's really important to recognize just how solid that is. Now a snap measurement that's over 80% of cranking compression means the air is being improperly trapped. Snap readings all over 80%. Look for exhaust restriction like a clogged catalytic converter. But if you got a bent exhaust valve push rod, a worn exhaust cam lobe, or a collapsed exhaust, the valve lifter, that kind of thing. These rounded off camshafts used to be something that were pretty prevalent on Chevrolet small block Chevys. And my dad, one time for $400 or $500, bought a '77 Caprice. It had a 305 in it, and and it had a rounded off camshaft. And when a camshaft was rounded off one of those, with had a carburetor on it, when it was running, it would go pop, 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 pop back through the carburetor. Whenever it like the exhaust valve would be rounded off, and the exhaust didn't have anywhere to go, but it would pop back out the intake, and that was a camshaft issue. And we pull the intake off and got the lifters out of it. Incidentally, if the lifters are mushroomed on the bottom, you got to be pretty crafty to get them out of there. There's a little trick where you pull the lifters up, the ones that won't come out, and hold them up, and then bring the camshaft out the front after you get the timing covered all off. And then what you do is you'd stick cut you a piece of an antifreeze jug and stick it in there under that lifter and push it down so that antifreeze jug will flex, and then when you get it pushed all the way through, then you can pull the antifreeze jug part out, and that'll give you your little lifter that you were trying to get out of there. The long and short of it is, anytime you tear one down, whether it's got roller lifters or whatever it's got on it, you need to look at those lifters very, very carefully. On the flat bottom lifters, you got to make sure they're not dished, and on the rollers, you got to make sure that the roller's in good shape and all that. To be perfectly honest, if you're going to do a good engine job, it's a good idea to throw a set of lifters in it anyway. Lifters, can be obtained most of the time without spending a whole lot. If you buy them online, or sometimes if you buy them at the parts store, they're not bad. Push rods usually cost a couple of dollars a piece. Building an engine is best if the push rods are hollow, to go ahead and replace all the push rods, $2 or $3 a piece, because it's difficult to get all of that crud out of the inside of the push rod. You don't really want that mixing with your new motor. But the long and the short of it is, we put a 350 camshaft, because that's all we had on hand. We put a 350 camshaft in that 305, or that 305 that was in that 77 Caprice, and that thing ran really good. But boy, did it ever suck some gas. Anyway, all right. Now then, get a low reading at idle, and also on the snap test, the cylinder is leaking compression somewhere. Bent or burnt valves, valve or valve leak, carbon buildup, worn valve guides, weak springs, cord cylinder wall, leaking head gasket. A cylinder leakage test might reveal the leak points. Here you want valve guide there. Okay, so this was like if it's low at idle and snap. So you got some compression loss in that cylinder somewhere. Excuse me, I don't think I've ever sneezed on a video before, but don't worry, you don't need a mask whenever you're just watching me on here. All right. I was working at a truck shop in the 80s for a while, and this is a little war story I've got for you. And this international gas burner came in from the local place where they process, chickens, a chicken plant, and he said, these people have been mad at us, the guy that ran the shop. And it was a pretty good sized little truck shop I was working at there. They also worked on semis and all that. I could tell you another story about that, but anyway, the point is, this truck came in and it was missing on one cylinder. And he says, let's see, that was two different trucks. I'm sorry, it wasn't the one from the chicken plant. This one came from a building supply place, because I worked on several trucks here, and I've slept since then. That was in the 80s, like 85, you know. Anyhow, so I says, all right, I'm going to find out. I found out which cylinder was misfiring. It was the front one on the right side. And international gas burner engines are weird anyway, because you timed them to cylinder number 8, which was strange. But the firing order was the same as the plane of a Chevrolet or a Dodge, you know, 1843652, those old ones. And I had no compression on that cylinder at all. I screwed the plug out, put the gauge in there, no compression whatsoever. But when I squirted a little oil down in there to do a wet compression test, the compression came up to 180 psi. And so I said, that is really, really weird. So what in the world would make it have no compression until I squirted oil in there and have the compression come up that high? I mean, that is a heck of a lot of compression there. Well, the number 2 cylinder, no compression, added oil, 180. That's what I told him. I told him what I found. He said, let's rebuild it. Well, I got the valve cover off. I found the problem. Some yo-yo had over-revved it, floated a valve, and dropped a push rod. The push rod, one of the push rods for that cylinder, was laying down in the valley. I fished it out with a magnet, put it back together. Really didn't need to be rebuilt. All right, so what a lot of people don't know is that a piston with good ring seal can create enough negative pressure in the cylinder on its downward stroke that the atmosphere can actually push the intake valve open and far enough to get some air into the cylinder. That's what was happening here. You can actually, some of y'all might have seen on some of the old Oldsmobile engines when they would break a rocker arm, and you would see them, you know, they'd be popping back through the intake. But the long and the short of it is, if you got good ring seal, like and the oil I squirted in there helped the ring seal better, it was able to actually pull that valve open and get enough air to where it had good compression when I was just spinning it over doing my static compression test. Anyway, what's wrong with this picture right here? You seen one like that? This was sent to me by a buddy of mine that works about 30 miles from here. We got a shop, a little country shop out there. And he took the valve cover off of one, and it had several valves that were like this. Some of them, this stud was popped off right where it came through there. And I'm going to say whoever drove that thing probably over-revved it and floated a valve, and he had pistons hitting valves and stuff at a really, really, really high rate of speed. It's astonishing to me that this thing could poke a hole through a push rod like that. But that's how he found it when he pulled the valve cover off. Some of you guys may have seen stuff similar to that. But anyway, all right, now it's time for a wildcard test. We're going to go ahead and let the test play, and we're going to see how you do. I know this was a short video. Incidentally, I had another couple of little stories to tell you from the truck shop before we go to our wildcard test. One day, this is a true story, this truck driver called ahead with his CB radio, and he said he was coming in to have some work done, and he had a cab over, big cab over Kenworth or something. So he comes pulling it right on into the shop, and so he just got out and went up front to have the ticket written. And the mechanic said, well, here's the truck, I know what has to be done to it, I'm just going to start working on it. You know, on those you have to, you know, jack the cab up. And so he started pumping the jack to jack the cab up. And you know, anybody that's worked on those knows when you start jacking the cab up, you hear stuff falling around in the side of the truck. Go bang, boom, boom, bam, 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 you know, tumbling out of wherever it's at, because you're tilting the whole cab. And it's a flat front cab, you know. And you get accustomed to when you get the cab past a certain angle, you stop hearing that stuff in there. He kept hearing it even when he got it jacked all the way up, and he stopped jacking it up, and he still kept hearing stuff. So he walked around to the front and looked up in the cab through the windshield, and there was a woman that had tumbled out of the sleeper and was thrashing around on the windshield. And that's a funny story. But there was another one where this, he said, this is one that came from the chicken plant. He said, this engine has a burnt valve. He says it's, and we know it's got a burnt valve, and we know which cylinder it's on. And we don't, they need this thing back this afternoon by 4 o'clock. And so right now it's 10 o'clock. And so we need you to pull the head off and take the burnt valve out and lap it, you know, put a new valve in there and lap it in. We just need her to do that one valve. We don't need to do a whole valve job because we're in a hurry and we're just going to get this thing back going for them. And they're mad with us, so we're going to get it back to them as soon as we can, try to do a really good job. So we need you to, give it your best shot. So I said, I can do that. So I rolled my toolbox over there with my little 3/8 impact wrench hooked up, and that tilt forward cab, you just walk inside the tire and you're standing there. It's like the engine's on an engine stand. It's real easy. And I zing, 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 zing. I popped the intake off of that thing, and I jerked the, got the rocker arms loose, the push rods out, and all that hogwash. And I got the cylinder head off, and then I laid it over on the bench and got the valve out, lapped the other valve and put it back in there, and I got it all seated and everything. And then I cleaned all those head gasket stuff out of the way. Cleaned them off, made it real smooth, scrape, sand, put a new head gasket on it, put it all back together, put the intake back on it. Started on it at 10 o'clock, started it up at noon. And he was so shocked that I got through with it so quick. Of course, anybody that's, pretty fast and has an impact wrench and knows exactly what to do can get done pretty quick. But, of course, I had to take the exhaust manifold loose before I pull the head off too. Anyway, all that stuff went by like a song. And everybody knows that's ever done any mechanic work is, even if you've done a lot of it, some jobs go faster than the other ones. Well, on that one, everything just kind of fell in place. I got that thing filled up, burped out, coolant burped out and all that kind of stuff. And he says, this pays 6 hours labor, and we're going to have to hang on to this truck for another couple of hours, so he won't think we put the screws to him by bringing it back and charging him 6 hours later for work that didn't take but 2 hours. Anyway, that was a fun little story that I had to tell on that. There was another time, when I was at the Ford dealership, I was working on a Lincoln, and you know how they had those Torx, the dome Torx head screws holding the stupid fuel rail on, and for some reason I had to pull off the fuel rail, pull the injectors out, and all that kind of stuff. And the screw was rounded out when turned, and so I got my little high-speed cutter and I, cut a little screw slot in it. And when I went to try to screw it off, one side of the screw popped off and went somewhere, and I said, good grief, I don't know where that thing is. And so I wound up having to just grind that thing off and then drill it out and retap it and all that kind of stuff. Well, when I put it back together, that little piece of half of a dome head screw had managed to work its way down, and I should have found the thing as soon as it popped off. It's one of those 20/20 hindsight things. That thing got down in there. That was one of those cars that just wouldn't let go of me. And when it got down in there, it got on a cylinder head and started up. It was making noise, and the head had to come off. That was one of those things that makes you really mad at the time, but you laugh about it later. But it seemed like every time I thought I was done with that car, it would get its hooks into me. And, there was something else I had to do with it. I was really tired of working on that particular vehicle by the time I got done. The last thing that happened was when I went to get in the car, you might remember that plastic handle up right under the middle of the steering column that you pull down. Whenever that thing had a bad spring on it. And when I got in there, slid in the car to back it out, my knee hit that handle and it broke off, and I had to go to the Lincoln dealership and get one of them $7 handles and put it back on there. But that was one of those cars that just didn't want to let go. The one that hooks into you and you're thinking, I'll be glad to get through with this car so I can go on to the next one, and it just keeps hooking you and hooking you and hooking you. Every time you turn around, there's something else that needs to be done. Anyway, I'm going to let the test go ahead and start. It won't take you that long to go through it. I hope this thing helped you out a little bit. It was kind of a quick run through the dynamic compression testing, but we will see you next time. I'm sorry I was late getting the video uploaded. I had a bunch of errands I had to run this morning, and we got a late start anyway. But we will talk to you later. Really appreciate your time.